Hello, everyone. Welcome to another series of performance and software automation. I'm Rodrigo Moutinho. It's a pleasure to have our special guest here today. He's a Java developer, blogger, speaker, one of the coordinator of MalagaJUG. He's an expert and DevOps lead in Accenture in Spain. And recently, I had the pleasure to participate on his talk on Article Code 1 in San Francisco. It was amazing to know all the great stuff about pipelines, use Jenkins, Docker, and OpenShift. So welcome, Jorge Hidalgo. Thank you for being here with us.
Hello, thank you, Rodrigo, for inviting. It's a pleasure to be here today and just have these few minutes of chatting of our experiences with pipelines, continuous delivery, and all that stuff.
Awesome. So just to start, so you could you tell us a little bit about your background on software industry?
So my background, well, it all started at 13 when my my grandparents brought to me a small personal computer from that time, an Amstrad computer, and it all started there. So I started to feel this common itch of I want to program this thing. I want it to do whatever I want. And then I continue working with computers also in university. So for computational in terms of simulations, numeric computation, all these kind of things that you do in university. And then I started in '99 working here in Accenture. I started as a junior programmer. Actually, as a Visual Basic junior programmer at that time. But shortly after starting, I was presented this new thing called Java. Well, I was fortunate to have my first projects working with Java and server-side JavaScript. It was a diabolical technology from Netscape that allowed you to make dynamic web pages. So, well, it all started there in '99. So I continued working as a developer, becoming more senior, at some point starting to also do architectural roles. No? So not just coding, but also thinking about the higher level picture, how to make things work, how to solve problems, which I really find very entertaining. And since that, well, I continue working in those technologies, went to Java, web, cloud native stuff, and in the last few years also looking at the DevOps side of things. So doing things in a different way, more efficient, more human also. Really, really happy with that, with a strong, good team helping me to push that forward.
Awesome. I like always to ask and consider that you have this awesome, great experience. At the beginning of your career, do you have any what would be your biggest nightmare you ever had related to doing manual steps and manual deploys? Do you have any funny stories?
That would be difficult to find just one, but if I wanted to select one moment, one really changing moment, it was related with JNI, so the Java native interface. So it was an API, for those that don't know about that allowed you to execute Java code from a native library, or the opposite, to execute native code from Java. So you always need to create a very complicated interface for making everything interoperate between Java and C. And I remember that every time that you make this tiny change in the Java code or just changing an interface, you needed to look at that. And it was manual, tedious, and very boring and error-prone. A lot of, very, very difficult to debug. So it was almost impossible to do it right, because you can imagine when you need to do these kind of things for Java code. So those are typical things that you don't have in Java. It was related with cryptographic modules and things that were not open by design. So I remember those days as like really horrible. Like, oh my God, I'm just repeating the same boring manual steps once and over again. It would have been great to just have a button and convert my Java program into this nice interface. So probably in one sense or another, in the career of any developer, you just start to always think about that. No, it's, oh, I have this task. I've done it 3 times. I don't want it to do anymore. I want to automate it. So it's, I think it's natural in how we do things.
Perfect. Yeah. Well, I totally agree with you. This, if you started doing these tasks, and you saw that is a little bit tedious, it's probably because you're doing so too often, and you need to automate. Yeah. Before starting the pipeline topic, do you have, in your opinion, what is the benefit of having like continuous delivery and continuous integration on projects?
Okay, so to answer that, I will probably look back in our history here in the office when we started doing those things around 2007 or so. So at the beginning, the thing that's really caught our mind is that we were able to do a lot of things in much less time. So we could add our favorite code profiling tools like checkstyle at the time and PLD. We could start to execute tests more often. We were able to create the packages that we were delivering the software in an automated fashion. So at the beginning, it was all about time, about saving time, and about also not making mistakes. So I remember the first project we started to do this. So we needed to create packages with the Java code in a complicated fashion because the client demanded for it. So you need to put the classes in a specific, depending on the role of each class. So the interface go there, the utility classes go there. You always needed to do a lot of manual tasks just to export the code in the right places from the IDE. So when we started doing that package, so it's like you create your first shell script, and then it's like you feel, oh, I'm doing the right thing. I want more and more and more. And it will start like that. Then you discover that as you are saving a lot of time, you can do those things much frequently because it's not like, oh, I need to spend 2 days to create this new release. Now I just need a couple of minutes, so I can do that every day. Why not? And I can start to release. Even if it is in non-production, I can start releasing every day. And I think that's really how it all starts, no? Have more meaning for our time as humans. We should be focusing always on the creative things and not on the manual and boring things. But then once you start to get all the automation and all the saving time, etc., is where you start to focus on the other aspects of continuous delivery, which is more on the human aspects, no? Be more responsible of what you do, really learning what are the impacts that your code and your configuration is going to have into others. Learn that technical debt is not just something that you see in a dashboard in a tool. It's really a concept. It's something that others are experimenting. You have probably well enough, and there is some other people who is not having as easy day just because you just not tested as sufficient. So I think that's then you start looking at the higher picture, and I think it's also very rewarding to work in a different way, to invite others to express freely, to fail, and just to learn from failure, so we ensure that there is no fails when it matters in production. So we are able to really react fast or learn fast and do things correctly. There will be always be technical debt because we cannot do things perfect just with the time we usually have. But at least you know that you have everything under control, that you are really managing your technical debt, that you are really focusing on the things that are important, and at the same time, be more, having this ownership into everything that you are doing. And I really love that, also that aspect of what's the spirit behind continuous delivery.
Yeah, we, as developer doing this kind of things, we have more time to code. So this is the all the benefits that you say. It's perfect. Yeah, I totally agree. And to start talking about the topic, you said you show us on the Code One presentation. So could you explain to the audience what is the pipeline and a little bit of the story of pipelines?
Yeah. So basically, the pipeline is like a realization of the concept of a factory, but for software. No. So we can imagine on a factory which is doing cars. So you have one station with some parts that are assembled, and there is another station when you add, for example, the canopy, or you add the dashboard, the steering wheel, whatever. So this production line is taken from raw materials into different stages. There are some quality tests in there. So there are, this does well done. Oh, the gene. Oh, that's correct. So everything has a place, and it's very, let's say, it's really a process for which we transfer the raw materials and the ideas into something which is well done, fit for purpose, and with quality. So if we try to apply that concept into software, at some time it's very tempting for people to just assume that every piece of software we build is the same. So this is fundamentally different from what we have in software, from what we have in just any other manufacturing practice. So for example, cars or furniture, because you just produce the same kind of sofa, and every sofa is pretty much the same. But software, not. Every piece of software is different, because in the digital world, if you want something the same, you don't need to fabricate it again. You just copy. So it's tempting to just think that we do everything the same, but the approach is still good, because we can standardize the process. We can think, what are all the things that we should do to transform my idea, for example, an e-commerce application, and the raw materials, which are caffeine, basically, and transform them into working software with the same, let's say, objectives that a car manufacturing industry. We want software which is fit for purpose, which is quality made, and that has all the right properties. So yes, our approach is really different, because we don't have really all the raw materials that you will need for a car. And obviously, every piece of software is different. But I like the idea of having a common pipeline. So every piece of software we build, I don't care about the language, the technology, or the purpose of it, should go through a series of standard process steps. No? So it could be compiling, it could be resolving dependencies, doing a static analysis for your code, testing, etc., etc., etc. So this is more or less the concept of the pipeline. No? All the things that you need to do to ensure that the code that you are creating is really what you are expecting to have in terms of the value it provides for any business. No?
I love the analogy that you make with the fabric, because it's something easier we can see the benefits, because all the fabrics is producing things on a very, very fast way. So this is why I think maybe this is the next question that I would like to ask you. Maybe you already told us a little bit about this, but what is the main importance of having this pipeline, or if you have any example that we can understand why it's better to do on this way instead of doing the manual step or things like this, or on a separate way?
So, well, first, I mean, we have already discussed about that, which is saving time. So that's for sure. You have everything automated and you have everything put together. The second great benefit is about ensuring quality and fit for purpose, because the building of the software is no more like a personal, very subjective matter. You can start to standardize or objectivize how you are considering the software to be complete. So it does not have any obvious defect, no security violations. For example, you don't have a dependency with some security, non-security vulnerabilities. Your code had a good coverage on tests, so you can be sure that if you make a mistake in the next release, you are going to code it, so you are not going to release that into production with a bug. So all these things that you are doing to ensure that the code is correct, at the end, make you be sure that you are doing the quality-made software, so our software craftsmanship is very there. Also that it is fit for purpose. So we are really doing what is expected to be done. So this means that we don't have unexpected issues once this is put in production. We we can get better client satisfaction because our users, our end customers who are paying for this software we are creating is really finding what they want. If you don't do this in a pipeline fashion, it's like you are always subject to acts of heroicity. So it's just the matter of individual developers doing the right things in the right moments. And we know we always have pressure for have this last minute rush for doing the right thing or some last minute change. It's always very tempting to just go to the point, code something, and just release it without properly testing. Really, with the pipeline, you know that everything that you do is going to pass through this pipeline to ensure that everything is correct before it's going to be pushed into production or to be released. Be sure that no matter what you do, this is also not going to create an impact. To give you an example, for example, in security, which is one of the areas that I'm trying to push more and more. It's like, how to say, at some point, I think that many people start to acknowledge that we need to do static code analysis, that we need to do automated unit testing, UI tests, for example, Selenium or whatever tool you are using. But still many projects, many people are not assessing security in their applications. It could be vulnerabilities that you have from code that you are importing, like libraries, etc. And we need to really be very wary of that because most of the code that we have in our projects is third-party code. Just to reuse the code, which is great. So doing those things is really not complicated, and there are a lot of let's say open source tools for that. But the risk that you are getting from not doing that is so high that really could put you in a very bad position. That's having an important vulnerability, you can be exposing internal data from your clients, so this could be quite catastrophic. So this is an example of how a small thing that you can do as part of your pipeline, as part of your continuous releasing process, is making really a difference. And at the same time, you can feel a bit more relaxed because you know that there is a tool and there is something in the process that will help you catch something, even if you forget about that. So I think that's also an important part of what's the pipeline, or why the pipeline is so important for us. Not just saving time, also giving us this peace of mind.
Awesome. Yeah. And on your talk, you gave us a very deep, detailed pipeline. So many steps on each type of each phases of the pipeline. Mm-hmm. But you have any minimal steps or good steps to have a pipeline? Maybe we are the ones that are starting. You have you need to have these 5 steps. This is the base of a good pipeline, so you can start to automate the project.
Okay, so I will say that the minimum stuff you should be doing is on your code. It's very cheap. There are a lot of tools for that, and you're getting a lot of benefits from that. So static code analysis will probably be number 1, and the automated unit testing will be number 2. Yes, you need to invest some time in doing the automated unit test, but the true, and I see that a lot in projects, in all the projects I work with, is that doing automated unit test is pretty hard the first time, the second time. So the first few tests are going to take you some time. And once you have set up them, you can create new test cases very quickly. And you will get this good feeling that with very small effort, you are getting a lot of testing. Something that you cannot do manually, because manually you need to test once all over again, the same things, the same steps once all over again. So with automated unit testing, you need to invest a bit more as a developer, but once you have done that, you are going to get a lot of return of that investment. And it will give you much more tranquility that what you're doing is the right thing to do. So this is probably the second step I will suggest. And number three, well, quite difficult to say, but I will say do security analysis. So check the vulnerabilities that you're using. It's also very easy to do and will give you a lot of benefits from your project. Once you have that, we will say that this is like the basic pipeline that you could build. You can start doing the more advanced things. So like packaging, deploying to a test environment, executing integration tests. So it could be an UI test, it could be an API test, or it could be performance test. So those are a bit more advanced. That with the right tools, you can find that they are very easy also to set up. And but what we wanted to show in the talk is that it's not that hard to do. And of course, we also have the exemplar code in GitHub, so people can take a look and try to make that work in their project, because it's pretty easy. And we have a lot of incredible open source tools for that. So that would be probably the second step, no? So integration test, UI test, performance test, etc. And once you have done that, you can just go full equip. And then you can look at continuous delivery, push into pre-production, push into production, ensure every time that you are doing the right thing. So you are not getting past any code which is wrong or with bugs.
Also, I will put the GitHub link from your project on the show notes, so everyone can see the whole project that you show us on the talk. And you're talking about tools, so you talked a lot about Jenkins. So do you want to explain how the pipeline works in Jenkins?
So the main motivation for Jenkins there is that, well, we know Jenkins as an automation server and continuous integration server, so this is nothing new. But not so long ago, Jenkins introduced the concept of pipelines as code. So the ability to model and describe this pipeline, this life cycle, this production line for the code in a very easy way. And I think that even more importantly, to have that pipeline part of the code. So when I check out a project from GitHub, from any other repository, I get the code, I get the configuration, I get the tests, but I also get the pipeline. So I know that my code, every commit I do to be considered completed, need to pass through all these quality gates. I also get information about dependencies. So if I need a database for running this, I know that because everything is described in this pipeline. So it's a great concept, very powerful concept. Many other vendors are already also starting to incorporate that, and many others did that before Jenkins, to be true to the history. But at least for me, it was Jenkins that opened the eyes for me that this was a really different and a really cool way of doing things. And probably it has been the one really popularizing that, because Jenkins is so widely used that people just found out of a sudden that, I have this plugin, let's check it. Oh, it's cool. So it was easy to start doing that. And really that's the point of Jenkins, not really the continuous integration side of things. This is not new, but having these declarative pipelines, describing everything in the code and making that code or that pipeline part of your repository. So everything is in the same place.
Yeah, and to add more, I think you already said about it. I think the community power on Jenkins, it's very, very big. So they have always new plugins, and they are always trying to release new versions. So I think this is one of the maybe the main things that everyone like to choose Jenkins, right?
Yeah, exactly. So I mean, we want to be really true to the history. Probably others like Go CD from ThoughtWorks were really showing us the way to go before, but at the same time, Jenkins has this huge community, and we were all using them. That really having this kind of approach in Jenkins has made everybody else looking at that and say, okay, that's the right way to do things. This is really the way in which we should be collaborating and sharing and promoting the use of pipelines in our software. So, well, probably others invented it, but Jenkins were the one that really find the nice place to make it easy and to make it accessible to almost everybody.
Yeah, and on your talk, you also talk about containers and considering all these containerized softwares that we have today. How and where can we get the benefits of Docker creating the pipelines?
So I get variations of these questions a lot. So at some point, people even think that containers, or probably thought that all this pipeline thing needs containers. Really not. I mean, you can be doing pipelines for everybody. So we are doing that in mainframe, even in SAP. So every technology can have their own continuous integration pipeline story. But the greatest strength of joining forces with containerization, like Docker, and orchestration, like Kubernetes, no matter what is the language I'm writing my software, no matter what are the libraries, no matter what are the frameworks, even no matter what is the middleware I'm using, if I can get it expressed as a container, I can have like much more easier to standardize this pipeline. Because at the end, I'm going to get my Docker file or my application YAML from Kubernetes, and I'm just going to have that as the seed I need to continue doing that. So that's really the power that we see for expressing pipelines. Before that, we did the same things, but it's true that every project needs to find the right, a lot of ad hoc scripting to make a deployment successful or to promote code from development to staging to production. With containers, it's much, much easier. You get also much, let's say, you can know much better what you are putting in production, because every image you create has a parent image, and the parent image may have another parent image. So you have a very detailed inventory of whatever you are putting into production. So it's everything under control, which is also great. And a third benefit of that is that you can also get Docker and Kubernetes, the ones that manage your continuous integration environment. So you don't need to tweak with agents, with slaves, because even for building the pipeline, you just have another Docker image. So you have your container for building new containers. So everything is a container. Even in Jenkins, it's a container. No? So it's a very nice model, easy to define, easy to manage. And I can assure you, once you have done that, and you think about like 5 years ago when you needed to have this farm of Jenkins slaves for managing all your builds and all the different problems that you can get from managing that, and you now think, oh, Kubernetes is making that so easy for me that you think, okay, I don't want to go back. So it's really, really great for us in that sense.
Yeah, and you already say a little bit about Kubernetes, but your talk you also talk about OpenShift. So you think this kind of tools can help even more developers to create this and use like Jenkins and Docker and the orchestration?
Yeah, exactly. At the end, I think that Kubernetes has established as the de facto runtime platform. Okay. So when we are looking everybody in the market, Kubernetes is already there. It's winning. It's a very nice piece of software. It does a lot of things for us. So it's now a matter of choice of the added value. So you can get Kubernetes in Amazon, in Google, in IBM, in Azure, or you can build it in your own premises or in your own virtualized hardware with OpenShift. With Pivotal, also have a container service based on Kubernetes, Rancher, I mean, a lot of them. So one of the cool things is with all these platforms is that they give you added value on top of Kubernetes. So Kubernetes is great, but at the same time, it could be quite complicated to stand up and to maintain and to scale it. So in our case, for example, with OpenShift, we get to a very nice point in which we can focus more on applications themselves, the dependencies, and the pipelines, and just the platform will take care of everything else. So if I just give OpenShift, okay, this is my repository with the Jenkins file, the Docker file, the application YAML, and whatnot, it would just do everything that is needed to make that software release. I don't even need to go into Jenkins because it integrates with Jenkins. So I know that I have Jenkins there as well as an application in OpenShift, but at the same time, the UI is getting the information from Jenkins thanks to the APIs, and I have everything in the same place. So it's very easy to consume, very easy to know what's happening, and just focus on the important things. So having good pipelines with good quality measures, etc., etc. But it's true that it's not, let's say, something which is specific to OpenShift. So other platforms are often bringing this kind of value. And there are other interesting projects like Jenkins X, which is also trying to aim into making easier the developer workflows when you are using Kubernetes as your runtime platform. So it's nice. I mean, and there is a very nice fight to provide more added value between them.
To have great tools. And we talk a lot about all this pipeline things and so on. But what is the main tool that you are using daily to automate things?
At the end, most of the day, what we are using is Jenkins because it's really orchestrating everything. We spend a lot of time in Visual Studio Code or Eclipse or IntelliJ, so the IDE is still like the king. We write our IDE, we write the code, we write the test. So it's true that at the end, the IDEs are making the AI more important than ever. In the same place, I don't need to go to different tools. Just what's the pipeline for this project? I have it in the IDE. And in terms of tools, yes, the IDE and Jenkins for everything else. We also look a lot onto the SonarQube as the quality dashboard. It helps us to get all the information from all the different tools. So not only do analysis with Findbugs or Checkstyle or PMD or CodeMark or whatever tool we're using, depending on the language. You can also get Sonar getting the information from your code coverage, from the integration test, from the performance test, having one nice dashboard that lets you get that information. And we are now starting to pay more attention to the monitoring tools. Okay. So how we can get more information about inside the continuous integration process to also learn from that in terms of performance, in terms of correct use of resources, so having like an agent getting this information. So this is something that we are starting to explore, but I think it's probably the next logical step. We have many tools which are doing great things. Now it's the time to start looking at all the information that we can get from these tools and learn from them to not just look at code coverage, so to speak, but also know about the things that are happening inside the process, which is quite nice.
Yeah, for sure. And what about the technology that you, the main technology that you love to use to automate?
Okay, so we are still mostly Java. Probably, well, it's great. We feel it's so familiar that usually I like to see to my colleagues that it's usually no matter what the language that you are using is how familiar you are with it and how productive you are with it. So we still use a lot of Java, but we also use a lot of JavaScript and Python, depending on some of the things that we want to do. And we are also, as a team, very excited with Graal, so the new VM technology, which is allowing us also to integrate into the same VM all the different code that we are doing projects. So now we can have a one VM for the Java, the Scala, the Ruby even, Python, R code, where we are doing some statistical computation, some machine learning computation with R. So it's really nice in terms of new technology that we are adopting fast in the project, and that we are really very excited with that.
Great, great. I love the way you said, because most of the time we always think only about shell script and things like this, and Java can help us a lot to do some kind of automation, and we already know everything about Java because we are developers. So yeah, I love
Exactly.
this tip that you gave.
Exactly, and we compare that with RAL, which allows you to create native images of your Java programs. You can get CLIs in Java, which are incredibly fast. So if you are good with Java, if you are proficient with Java, do it with Java. There is no technical limitation for doing that. Of course, there are other people in the team that prefer to do that with Python, so that's great too, because we must adapt the language and problem we have, and also to our knowledge. So I think it's great that we have the options.
Yeah, perfect. And the final one, what is your best advice for those that want to automate their software delivery and avoid the dependence of hero developers?
Well, I will first say is that they need to be empathic with the operation teams. Okay, trying to be in the in the minds of these people that is going to get the software that we are releasing, and then ensuring that it's working perfectly every day, every moment. So the moment that you start looking at what others are having, you start looking at your code differently, and you start to care a bit more about what you have written. So this is probably the first step, because at that point is when you realize that pipelines is not like the next shiny toy that you need to do because it's cool. It's like, I'm a software engineer. I need to be proud of what I am doing. The same that someone from a famous car manufacturing can be proud about their product. So we need to feel that kind of proud. And then it's when you think is that I automate things because I want to write better software. And I put all this automation into pipelines because I want to be sure that I never miss anything. And then just the rest will just come naturally, I think.
Perfect, love it. Yeah, great advice. Do you have any final thoughts? Something that you want to promote, share with us?
Yeah, I would just like to say, say that about is that we live in a fast changing technology landscape. So I would say, no matter how much you love a language or a tool or whatever, we be always, curious to learn about others. Know more about other tools, technologies will probably make you a better engineer in the longer term. Even if you still prefer to do everything with just Java or JavaScript, whatever you prefer. So learning from others is always very, really great.
Awesome. I will also put the meetup link for MalagaJUG, right?
Yeah.
On the show notes. That's one of the things that I know that you're leading. And man, thanks a lot for being here with us. And it was a very good interview. And everyone that wants to know more about software automation and to avoid the hero developers on the team, subscribe to cyborgdevelopers.tech, and you'll receive great information and notification on the upcoming interview that we are doing here. So I think that's it. And so see you.
Thank you very much.
Next time.
Bye.
Bye.